Alright, today we're going to talk about triangle congruency, or congruent triangles. So we've been talking about congruent segments and congruent angles, and we said that if things were congruent, then their measures were equal. Well, what if we talk about a 2D or even a 3D object? How can we talk about it being congruent? So that's what we're going to talk about today. So let's go back to what we were doing before. We were doing transformations. And so here is a composite transformation, and what we want to know is, looking at triangle BDF, how does it map on to KCA? What happens? What did we do? What kind of transformations did we need to do to get there? So take a minute and look at it. We'll pause for a second, take a guess, talk with your partners and see what you have, and then we'll come back. All right, let's see what had to happen here. First, we had to rotate it 180 degrees counterclockwise so that it's in the same position. Then we had to do some kind of a translation, so some kind of a glide rotation there to get it to move into the position where it needs to be. So we can see when we do that, that all of the angles match up, all the sides match up, and it is exactly the same shape. It was just a transformation. Well, transformations like rotations, reflections, and translations, they're also known as congruent transformations because they don't alter the relationship between the points that they map, meaning it looks exactly the same, it's just in a new position. We haven't resized it, the angles are all exactly the same, meaning they are congruent. So what does it mean to be congruent if it's an object? Well, all the corresponding sides and angles of two or more triangles are congruent. Then the triangles are congruent. Okay, let's go back and think about that. So meaning that when we looked at our last picture and we rotated, it matched up exactly on top of each other. All the angles were exactly the same, all the sides were exactly the same, they were all corresponding to each other, and they were congruent. So if all the sides are congruent and all of the angles are congruent, then the triangle is congruent. So let's take a look at this picture. We're given that triangle BDF is congruent to triangle KCA. So looking at the pictures, I would like you to write the corresponding angles. What angle would correspond in triangle BDF to angle B as it would in triangle KCA? So please write underneath what the corresponding angles are. Angle B is congruent to, write it down. Segment BD is congruent to, write it down. We'll pause here so you have a chance to write it down, and then we'll check our answers. All right, let's see how they mapped up. Now it's already labeled for us, so that's pretty easy. So we have, oh wait a minute, guess what? If we have a congruency statement, which is that what we have, a triangle BDF and triangle KCA, it's actually telling us the order that things match up. So angle B and angle K are congruent. Angle D and angle C are congruent, and angle F and angle A are congruent. They match up. That also means that our sides, segment BD, would have to correspond then and be congruent to triangle KC. And DF then would be congruent to segment CA. And let's see, if I go first and last letter, that's segment BF, it's going to be congruent to first and last letter KA. So if we have a congruency statement, it's telling us all the stuff that we already need to know and how everything matches up. Pretty cool. All right, so now I'm not giving you a picture this time. I'm just going to give you a congruency statement. So I'm giving you that triangle GEO is congruent to triangle FUN. Get it? Get it? Okay, so what I want you to do is I want you to name, using the correct notation, all the angles that are congruent to each other and all the sides that are congruent to each other. We'll wait a minute and let you go. All right, let's take a look at it. Remember, we're going to go right in order. So the first letter was G and the first letter was F, so angle G is congruent to angle F, then E to U and O to N. Same thing with our segments. So segment GE is congruent to FU, EO to UN, and GO to FN. So even without a picture, if we have a congruency statement, everything matches up. So if the triangles are congruent, then all their corresponding parts are congruent, or the corresponding parts of congruent triangles are congruent. Now that's a mouthful, and we're going to use this for proofs the entire chapter, and I don't know about you, but I don't want to have to write out corresponding parts of congruent triangles are congruent. And so we don't. We write CPCTC, corresponding parts of congruent triangles are congruent. All right, say that 3 times fast. CPCTC, CPCTC. You're going to say it a lot this chapter. All right, so now we have a diagram for you, and it is not complete, but I have given you that triangle EFG is congruent to triangle OPQ, and we can see they would match right up on top of each other. So what we need to do is we need to complete the information that they've given us. So let's see, what do we have here? If angle E is 110 degrees, then that would mean angle O would also be 110 degrees since they match up. And segment EG would be 7 kilometers, and so would segment OQ. All right, so let's see if you can finish filling in the rest of the information there. We'll pause for a minute, check with your partners, and then we'll check your answers. All right, so using the congruency statement and the pictures, we have segment EF is congruent to segment OP. Angle P is going to match up to angle F. Angle G is going to match up to angle Q. Angle O, the measure of angle O. Well, the measure of angle O would be equal to the measure of angle E, which is 110 degrees. Remember, measures are equal, things are congruent. And we actually have a number there. So now QO, that's not segment QO. We see the equal sign. It's looking for a measurement there. So QO maps up to GE. So the unit measured there is going to be 7 kilometers. And, ooh, they put it in a different order. Can we do that? Can we name it in a different order? So if I call it triangle GFE, how did my congruent statement change? How did the order of the letters change? Because the order matters. And you should have had triangle QPO. All right, last example. I'm giving you these triangles. And I'm going to tell you they're congruent. So what I want you to do is do the transformations, rotate them around, see how they map up, and then give me a congruency statement. And remember, the order of the letters of the first triangle is going to dictate the order of the letters of the second triangle. So I'm going to give you a minute to try and do that, and then we'll come back for the answers. All right, now remember, there's a lot of different ways to name this. In fact, there are 3 different ways to name this. It depends on how you name your first triangle. So if I called my first triangle cat, then it would be congruent to triangle God, not dog. When you rotate it and flip it around, it would be triangle GOD. But now if I changed the order of the letters on my first triangle and called it triangle ACT, then it was going to map up to OGD. And the last way we could do it then would be ATC. And that would map up to triangle ODG. Now actually there's a few more, right? I could have gone backwards, triangle TAC, triangle TCA, or triangle CTA. So there's actually 6 different ways we can name this triangle and have 6 different congruency statements. The important part is that all the letters match up so that all the angles are congruent, and the segments are also incongruent in the order that they're in. And so that's what we're going to practice for tonight's homework.